Dr. Memari again with another pre-lab discussions. Pre-lab discussions for experiment 3, which is recrystallization of organic solids. Recrystallization, just like distillation, is a technique for purification of the compound. Recrystallization is used for solid compound. Distillation is for purification or separation of liquids with different boiling point. Recrystallization, however, is used for separation or purification of a compound that has different solubility compared to the impurity components from its own impurities. The purpose for this experiment is to learn about theoretical and practical aspect of the recrystallization and how to do the experiment. Okay. When we talk about recrystallization versus crystallization, say crystallization, crystals are coming from out from a liquid. So if your liquid is like saturated at with a high concentration, then or it's super saturated, you wait long enough, crystals are going to form. And when it's recrystallization, you start with the solid. So you already have crystals. You're going to dissolve it, and then you're going to recrystallize again. That's the difference. Another term about precipitate versus crystals. Precipitation is like something like when it says precipitation, like rain, snow is like pouring. Is like a fast formation of it's a formation of solid, but it happens so fast that molecules, they are not selective. They're not going to organize proper shape or organized shape of the molecules. But in formation of crystals, you give enough time to the molecules to stack one over another. And because they have like proper arrangement, impurities are not going to fit in there, and you get crystals that they are pure. So you have to be careful not to cause precipitation. And what are the general steps for recrystallization is that you have to have a proper solvent for recrystallization. So you are going to dissolve the sample at the high temperature in minimum amount of hot solvent. And you're going to crystallize the purified compound. You would dry the pure compound and then analyze the product. What do we mean by analyzing the product? So we have a solid compound. We measure the mass of the product. We always calculate it, and we can calculate the percent recovery. Let's say if you start with 1 gram, how much you're getting. If the percent impurity was given to you, then you can argue and you can defend that your recrystallization technique or the solvent that you used was very efficient. You can decide on that. You analyze your product by measuring the melting point. So when you measure the melting point of the sample that is not pure, you would get broad range of melting. For a pure sample, you would get a sharp range of melting. If you know the name of your compound, then it's going to be, there is a literature value for the melting point of that compound. So let's say your compound is impure urea. Impure urea is going to melt lower than 130 and is going to give broad range. After you purify it, it should give a melting point very close to the literature value, which is 134. And it also should show a sharp melting. Now, what is ideal recrystallization solvent? An ideal recrystallization solvent is a solvent that would dissolve the sample at high temperature, but it doesn't dissolve it at low temperature. That's for the sample. Impurities, they are either highly soluble, means that they would dissolve at low temperature also, or they are not soluble at high temperature. If they are not soluble at high temperature, they are known as insoluble impurities. Sometimes you are trying to you dissolve the sample in the solvent, you find the proper solvent, you dissolve the sample in the solvent, you cool it down, and you're not getting crystals. The solution would be like induce crystallization. How would you induce crystallization? There's a possibility that you use too much of a solvent. If you use too much of a solvent, the solution is not saturated, you will not get crystals back. So you have to make sure to get excess of the solvent evaporated to get saturated solution, then you cool it down, you will get the crystals. Cool the solution in ice bath for longer time. Solubility directly proportional with temperature. The higher the temperature, the higher the solubility. So if you lower the temperature, the solubility would be low. That means more crystals are going to form, or the crystals will start forming. If the solution is saturated, or if it's super saturated, then to start the crystals, you are going to scratch the container, the glass container, using a stirring rod, or add like pure sample, like few crystals of the pure sample as seeding the crystals. When you scratch with the glass, the particles of the glass can act like a seed, so provides the nucleation site for crystals to form, or when you add the seed, which is the pure sample, also provides the nucleation site, and then crystals would form. There are some points that you have to follow in order to get high % recovery. So basically you don't lose the product, and pure sample, of course. You want to use minimum of hot solvent. For obvious reason, you want to make sure your solution is saturated. Use boiling chips, bumping. Anytime you heat up or boil a liquid, you want to add the boiling chips to avoid bumping. If there is no insoluble impurities, you don't have to do hot filtration, because if you do hot filtration, most likely you're going to lose some of the product. And if there is insoluble impurities, that means the solution is boiling or near boiling, and there is still solid particles in there. That means they are not going to dissolve. And remember, you should not try to dissolve the boiling chips. Boiling chips are boiling stones. They're not going to dissolve. So don't work too hard for that. And if there is no insoluble impurities other than the boiling chips, no hot filtration. Cooling is slow. That's the before putting in the ice bath. That's one of the cases that you could get precipitation. If you have a hot solution, you put in the ice bath right away, a sudden cooling is going to cause precipitation. When the sample precipitates, because is coming to solid, like all of a sudden, it can trap impurities, it can trap solvent, it can oil out. So you want to avoid all of that. Cool down slowly to room temperature, then place in the ice bath. You want to wash the crystals with cold solvent when you are doing vacuum filtration. Why not room temperature? Because you don't want to redissolve your sample. So you want to wash it with cold solvent. You want to dry your sample completely before you measure the melting point. Why is that? Because if your sample is not dry completely, there's some solvent left there. That solvent would act as impurity. So your sample is going to melt at lower temperature. If the sample is not dry completely, the solvent that is remaining there it adds up mass also to the compound. So you get like high percent recovery, and false, that is false, because you can't get more than acceptable range of the recovery either. So you want to make sure your sample is dry completely before you measure the mass or the melting point. And please make sure to read the experiment 3 before you take the pre-lab quiz or start the experiment. Reading the experiment is going to help you a lot because it covers everything about the recrystallization. Thank you. That's end of the pre-lab discussions for experiment 3.